Okay, sketch the curve. So that to sketch the graph of 2x cubic minus 3x minus 12x plus 1, first we need to find the y-intercept, the critical numbers, the monotonicity interval, whether the function is strictly increasing or strictly decreasing, the local extremes, local maximum or local minimum, the concavity intervals, and the inflection points. So to find the y-intercept, make x is equals to 0, so that it will be 0 plus 0 plus 0 plus 1, which is 0, 1. So that the y-intercept is at 0, 1. The second question is to find the critical numbers. Critical numbers are numbers at which the first derivative will be 0. So first we need to find the first derivative. The derivative of 2x cubic is 6x square. Derivative of minus 3x square is minus 6x. Derivative of minus 12x is minus 12. Derivative of 1 is 0. So the first derivative will be expressed as 6 into x square minus x minus 2. X square minus x minus 2 can be expressed as 6 into x plus 1 minus x minus 2 using factorization method. So to find the monotonicity interval and the local extremes, we have to find or to sketch the sign chart first. Remember that minus 1 and 2 are critical numbers, so that x plus 1 is 0 at x is equals to minus 1, so that it will be negative if x is less than negative 1 and positive if x is greater than negative 1. X minus 2 is 0 at x is equals to 2, so it is negative if x is less than 2 and positive if x is greater than 2. Then f derivative at x is the product of the two, so that negative times positive is positive, positive times negative is negative, positive times positive is positive. So the first derivative says if the first derivative at x is greater than 0, then it will be strictly increasing, so that the function is strictly increasing. Between minus infinity up to minus 1 and 2 up to positive infinity, strictly increasing. And it's strictly decreasing between minus 1 and 2, since the first derivative is negative at between the two intervals, between the interval minus 1 up to 2. The other thing is local extremes, so that as you look from the sign chart, the function changes, or the first derivative changes sign from positive to negative at x is equals to minus 1, so that f of minus 1 is local maximum. So the local maximum is at minus 1, which is minus 1, 8. If the first derivative changes sign from negative to positive at x equals to 2, the first derivative changes sign from negative to positive at x equals to 2, so that f of 2 is local minimum. So that the local minimum is at 2 minus 19. And to sketch the curve, first we need to find the concavity interval and the inflection point. So to find concavity interval and inflection points, first we need to find the number at which the second derivative is 0. Remember that the first derivative is 6x squared minus 6x minus 12, so that the second derivative will be 12x minus 6. So that 12x minus 6 is 0 at x is equals to 1 over 2. So f of 1 over 2 is inflection point. So that if we substitute in the original function 2x cubic minus 3x squared minus 12x plus 1 over 2, then the result will be minus 11 over 2. So that minus plus 1 over 2 and minus 11 over 2 is the inflection point. Inflection point is a point at which the function or the curve changes sign from negative to concave upward to concave downward. If you have a graph just like this, so that the graph is concave downward, then we will have inflection point, concave upward, inflection point, concave downward, inflection point. So inflection point is the point at which the curve changes from concave downward to concave upward, or from concave upward to concave downward. So that the inflection point is 1 over 2 minus 11 over 2. Finally, the concavity interval. So the second derivative is 0 at x is equals to 1 over 2. So the second derivative 2x minus 6 will be negative if x is less than 1 over 2, positive if x is greater than 1 over 2. If the function or the second derivative is greater than 0, if the second derivative is greater than 0, then the function will be concave upward from 1 over 2 up to positive infinity. If the second derivative is negative, then the graph will be concave downward. So it's concave downward between minus infinity and 1 over 2. Finally, we will have the graph. The graph has local maximum at minus 1, 8, local minimum at 2, minus 19, inflection point at 1 over 2, minus 11 over 2. Then the graph is concave downward from negative infinity up to the critical or the inflection point 1 over 2, minus 11 over 2, and from the inflection point it will be changed into concave downward, inflection point, concave upward. And remember that the graph is strictly increasing from negative infinity up to minus 1, and from 2 up to infinity. The graph is strictly decreasing from negative 1 up to positive 2. Thanks for watching.